So we're now going to talk about using a semaphore to mediate access to shared resources. And this particular example will look very familiar because it's essentially our Palantiri simulator use case. So as you know, we have the Palantiri simulator assignment, which we use as a running example throughout the course. And the basic idea is to be able to limit the number of beings who can concurrently gaze into a fixed number of Palantiri. And you're probably sick and tired of Palantiri by now, but it's a great example of a shared resource. If you're familiar with Tolkien, you know that there were a certain number of Palantiri that were created. I want to say they were created by a famous elf named Fëanor. I might be getting that wrong, but I think that's my knowledge of the Palantiri origins. He also created the Silmarils, which were famous jewels that are figured prominently in the Silmarillion, and will also, of course, undoubtedly be part of the upcoming Amazon TV series on Lord of the Rings that should be released later this year. So in our particular use case, each being, be it Gandalf or Frodo or the Dark Lord Sauron and so on, is implemented as a separate thread, and they're going to share a smaller number of Palantiri. And you, when you configure the app, can dictate how many Palantiri you want available for gazing at any given point in time. So let's just say, for sake of argument, we have 2 Palantiri available and we've got 5 beings, and therefore we can use a semaphore in order to ensure that there's only 2 beings that are gazing at any given point in time. Now, why might you want to restrict the number of things that can access these shared resources? Well, one reason is to try to avoid using all the cores on your machine. So if you had a quad core machine, but you didn't want to have 4 beings all gazing at the same time because you wanted to have other cores available to do other things, you could simply limit the number of resources, or in this case, Palantiri, by fixing that number. Remember that a permit has to be acquired from the semaphore before the being can gaze. And remember, when you go to acquire the semaphore, it'll try to decrement the count by 1. If it's able to do that and the count remains greater than 0, then away you go and you can go off and gaze. But if you decrement by 1 and the value is 0, then you have to wait. And so in our particular scenario here, after 2 beings are off gazing, let's see, it looks like we have Gandalf the White and Sauron gazing. Of course, in canonical Lord of the Rings, they never gaze at Palantiri together, but they could, in theory, I suppose. At this point, the number of permits is now 0. So that means if anybody else comes along, like Pippin or Aragorn or Boromir, they're going to have to wait. And so they'll wait until the count goes greater than 0. And when, say, Gandalf gets done, he'll return the Palantiri. He'll increment the count by 1 when he releases the semaphore, and then somebody else can wake up and start to gaze. So that's the basic idea. Really good example, by the way, of concurrent resource allocation and management problem, which is why we use this as the basis for all the examples in the course, because it's just a classic concurrency problem that's been around for a long time. You can imagine other use cases in computing, things like a license server that's a floating license server where you want to allow up to N people to use some copy of Adobe Photoshop or Premiere Pro or whatever, and you could have a floating license server that doles out licenses until you reach the limit, and then it'll make people wait until a license is available. This is also an example of fully bracketed semaphores, where the thread that acquires the semaphore, or the being that acquires the semaphore, must be the same one that releases it. It's not always required to do that. It's just the way this particular example works. Here's a UML sequence diagram that kind of illustrates the way in which the code works. This is useful because it helps to give the big picture view of what's happening without getting too wrapped up in the syntax. So what we're going to have here is we've got ourselves a thread, which is, we call it the Palantiri presenter. And that goes ahead and starts a bunch of being runnables that run in their own threads. So we've got N of these beings that are running in their own threads. And of course, once you start a runnable, its run hook method gets called. So each of those threads will be calling run. And each of those threads will then attempt to acquire the Palantir or a Palantir from the Palantiri manager. So let's say, for sake of argument, that we've configured the system to have 2 Palantiri, and we have 3 threads that are trying to acquire. Well, what'll happen in that case, of course, is only 2 of them can get access to the Palantir, the 8 Palantir before the count drops down to 0. So once they acquire it, then they can go ahead and gaze at the Palantir for some a period of time. And then when they're done gazing, they will release the Palantir. And at that point, the thread that had been blocked, waiting to acquire it, will now start to be able to gaze. And this is a good example of why we want to have FIFO semantics or fair semantics for our semaphore. Because if it wasn't fair, then as soon as one thread got done gazing and it turned around and tried to acquire the Palantir again, it might get it again, which wouldn't be very fair, because then one being would end up being given priority over always being able to gaze, and some other poor being would be starved from being able to gaze. So that's another example why we choose to use FIFO here, so that everybody gets a fair shot at being able to gaze. And of course, when that thread is done, it'll go ahead and release it as well. So that's just a quick summary of the use case we're looking at here. And we'll take a look in a second at a different use case that uses semaphores in a different way. But this is kind of the classic way of doing it when you're sharing a set of resources using semaphores.